since the PEA has been completed, we have drilled an additional 10,000 meters, and that was mostly in field and is really to help us upgrade the categories of resources so that it can be used in the pre-feasibility study.
Well, hello and welcome to viewers tuning into Assay TV. We're pleased to be featuring Defense Metals, who are exploring and developing North American rare earth deposits. And I'm catching up with Luisa Moreno, who's an analyst and expert from within the critical raw materials industry already, and of course is president of Defense Metals as well. So Luisa, welcome.
Thank you, Adam. Thank you for having me.
Yeah, it's great to be catching up with you on the projects. And look, we're talking about your Wicheeda Property. It's 100% owned by the company, and you've got a lot of mineral claims there covering quite a large area. Why don't you take the viewers through some of the company-specific achievements that you hit throughout 2022, and then we can go into this year from there.
Sure. So as some of shareholders of Defense may recall, so we first put out the preliminary results of the PEA in late 2021, but it was actually filed early 2022, was completed, and we filed that. So we were very happy to have completed that important step in the project development. Other things really important that happened as well is that as we sort of published the data for the PEA, we immediately started making significant changes. One of the most important changes that we made, and we did lots of metallurgical tests for that, was effectively the flow sheet, the hydrometallurgical part of the flow sheet. We, in the PEA, we had a caustic crack process, and then in late 21 and in early 22, 222, we started testing this new process. The reason for that was because we believe that it would give us better recoveries and potentially gains as well in CapEx and OpEx. So we have definitely seen significant differences in recovery rates that should help the economics of the pre-feasibility study. So that is one thing that we really did. We published some of the results already, both for the hydromet part as well as the flotation. So flotation comes first. We did more tests in flotation. We optimized that part, and we saw as well good results. We able to upgrade anywhere from 10 times to 20 plus. From relatively low grades. So we tested grades of 2%, 3, 4, and so forth, and we're getting, more than 40% total rare earth concentrate, mineral concentrate, which is essential to make a rare earth project viable. So throughout the year, we have been doing lots of metallurgical tests, lots of drilling as well. So we ended 2021 with about 5,000 meters of drilling, which is not included in the PEA. The PEA only has about 4,200 meters. So at the end of 2021, we drilled 5,000 meters, and then this summer, last year summer, 2022, we also drilled another 5,000. So since the PEA has been completed, and we have drilled an additional 10,000 meters, and that was mostly in field and is really to help us upgrade the categories of resources so that it can be used in the pre-feasibility study.
Yep. Excellent. Well, lots of wonderful milestones within that. I just wanted to focus on this mineral concentrate that you've got of rare earths and talk about, is it clear yet what some of the elements will be within that, and how through the processing where your end usage might end up in terms of the...
Absolutely.
Yeah.
Yes, we have known this for a while. So Defense Metals has experts in the area would call a light rare earth deposit.
Yep.
And what means is that we have relatively high percentages of lanthanum, cerium, neodymium, and praseodymium, more so than a deposit that is sort of skewed towards the heavy elements like yttrium, that would usually take a large percentage in a heavy deposit. Plus, they'll have more dysprosium and more terbium as well, which are two important elements for magnets. But the two most important elements for magnets, which is neodymium and praseodymium,
yep.
we have those in our deposit because we are skewed towards the light.
Yeah. Okay. Excellent. That's good for understanding this that sort of end use case. Okay. So you mentioned the PFS that you're working towards later this year. Could you tell us how you're going to continue to define the resource and some of the milestones and the data required to get that in place? Sure.
So we continue to optimize the flow sheet. So we are expecting to be able to finish all the tweaks for be ready for the pilot plant sometime in late March, perhaps mid-April, the latest. And that's going to be quite significant because with the start of the pilot plant, we should be able to start gathering the metallurgical data that will be used then to complete the pre-feasibility study. So right now we continue just tweaking small details in terms of temperature, reagent uses, things like that, which it just will make the pilot plant call it cheaper or more efficient to run. Once you have done all most of the necessary bench scale tests in support of the larger pilot plant tests. So we continue doing that. There has been some delays as well with the lab. We essentially use SGS Lakefield in Canada, and they are experts in rare earths and many other strategic materials. And fortunately, they've been really busy because the sector there's a lot of interest in strategic materials, but that also limits our ability as to when we are able to start the pilot plant. First, it was our fault, I would say, because we delayed it with the tests. And now they're really doing their best to accommodate us. And I think by sometime late March, mid-April, we should be able to start the pilot plant.
Yeah, excellent, wonderful. It's really a good year for ramping up this project. So in terms of your capital flows, the cash flow, in terms of the costs of the PFS, and how are you carrying your capital from last year into this year and getting this work done?
Sure. So the PEA states an estimate of about $16 million Canadian to complete the pre-feasibility study. And that is a good chunk of money, even though our market cap is now probably higher. I haven't looked at it this morning, but I think it's around 60 million. Even though that's the case, we do want to stage the funding, as we put good metallurgical test results out, as well as you might have seen lots of very good grades and large intersections, results from our drilling program, which the market has reacted very well to. So it's very good. We raised 6.1, just over $6 million, at the end of last year, and we're still likely going to raise another 10 million, but probably 5 and 10, depending where the stock is and the market conditions. But we will return sometime again to the market. But right now we're very well cashed. And we are in a good position to do the pilot plant.
Yep, excellent. That's great and reassuring. We speak of the markets, and obviously it's a challenging time for any sort of smaller cap or junior company. Equally, rare earths are getting more recognition, globally, as we need to move towards critical resource supplies and realigning supply chains. So I wonder if you could comment a little bit on the heightened strategic importance of rare earth elements and where they fit within, national government agendas, and whether there's enough support coming down from the top, or maybe not yet enough, despite some wider recognition. What's your view?
Right. So I think there has been quite a lot of recognition just in terms of press releases out of the government. It's funny, sometimes they like to say critical metals or critical materials and rare earth, almost separating it, which sometimes is just more because of definitions. Sometimes people get stuck in calling rare metals everything that is relatively rare, at least in the Northern Hemisphere in terms of production. But there is recognition of rare earth being important. As you know, they're not necessarily used in lithium-ion batteries, but they are critical for electric vehicles. They are used to make the most efficient, permanent magnet motors, the most efficient electric motors for electric vehicles. And they used as well in, other motors for the power windows and in other parts of the car as well. So not just the neodymium, praseodymium, but as well as lanthanum and cerium and others. So they're definitely very important for the production or supply chain of vehicles, period, but more so for electric vehicles. And estimates is that between now and 2030, we will probably need to increase production by 200,000 tons of rare earth, when world production today is about 250, give and take. So it's quite significant just for one application. And obviously, demand for the other applications continue to grow, because if you look at 2012 production was about 110,000 tons. And last year, well, the estimates for last year have not come out, but in 2021, it was, like I said, about 250. I think USGS has 280,000 tons. So there has been a normal increase in demand in the last 10 years for many other applications. Now, if you add electric vehicle demand, we probably will have to double the production of rare earth in the next 7 to 10 years, call it. And so, yes, governments have recognized for sure that there is demand, there is need for rare earth. And so in terms of building the supply chain, it's important to mine, of course, and have the materials, but it's also very, very important for us to be able to separate those elements, make metals for certain applications, learn how to make magnets in electric motors, or whatever other end products that we need for the products, for the technologies where these materials are used. So in terms of, just to answer directly your question, in terms of what the government is doing, I think there's a lot of focus downstream, but upstream, we haven't seen any direct dollars really coming to us. In Canada, we have the flow-through program, and there has been some support on that, but we haven't seen favorable loans or grants, or much in form of grants. I think each province has a little bit of money, sometimes $200,000, $300,000, but no sizable amounts of money yet going into the rare earth space, or frankly, the strategic metal space that I could see.
Yeah, certainly. Always room for new capital, but it's interesting. So the impetus doesn't follow the headlines as such. But that makes me think of the supply chain challenges, and what's the interplay here, or the opportunity, I suppose, for helping projects like yours get into production. and wrestling some of the supply chain dominance that China has, obviously, over the rare earth sector. I wonder if you could comment on that.
Yes, I mean, because junior mining companies, for the most part, raise funding for their projects in the capital markets, we are very much subjected to the up and downs of the economy, the up and downs of the stock market. And so that is likely to bring delays if we don't see a little bit more direct support from the government, just like strategic metals and rare earth companies in China have benefited over the years. It's definitely a model that they have. In the West, I think we are more comfortable saving the automotive industry and manufacturing, all these downstream businesses and industries than really investing or supporting or saving the miners. So it could be cultural. I don't know, but it is not that in the West we don't support companies. We see that happening all the time. Some people might accuse some countries of being more socialist than others, but and obviously China does that all the time. So when a sector like the junior mining sector is really struggling to keep pace with the deliverables that we need, or just delivering more material to the downstream industries that are being developed, so that the net zero or the carbon neutral programs can be fulfilled, I think that it would be really important for the government perhaps to intervene a little bit more in terms of funding support.
Yeah.
If we don't do that, China will continue to dominate in the near future. That's what I believe, and that's what we're seeing.
Yeah, certainly. There's some encouraging moves in the sense of the automotives looking more upstream. Obviously, GM and Lithium Americas is the case in point this week. But that's a producer and it's in lithium, so it's taking time. And there's not enough of it happening. So we can say there's sort of positive movements on the private sector side, but definitely not enough, right?
Definitely not enough. So GM it's an automotive company, and obviously they're trying to secure lithium for their batteries, but whatever is going to be produced by the lithium company, Lithium Americas, if I'm not wrong here, it's not going straight to GM. So it has to go through a company like BASF or Umicore first, some chemical company, then they mix the lithium with nickel or manganese or cobalt, depending the type of chemistry that they decide, and those materials have to exist as well in the right in the right form. And then once that is done, and then it goes to a battery plant that may or may not be owned by GM, and those batteries then finally will go to GM. So there is some steps in between.
Yeah.
But it's good that GM is taking the initiative of saying, hey, here is cash, here is money.
Yeah.
Hopefully this will fast track your production and allow us to have these materials faster. But it is complex. It's not just, the Bryan company produced the lithium carbonate or hydroxide, and then all of a sudden GM has the products. No, that's not the right form for GM still. We still have to develop the supply chains, and US is doing a good job. They do have battery, plants that they're building, and chemical companies that are ready to produce the precursors and other products that are needed for those batteries. And in the rare earths, it's going to be no different, right?
Yeah.
So we will mine these materials, we'll produce them, a chemical concentrate, but like I said, we still have to build the supply chain. We would love to be part of that, but we have to separate these elements, refine them with specific, characteristics. In some cases, we have to make metals. Somebody has to make magnets. We are a mining company. I don't think we want to make magnets. And then deliver it to an automotive company. And to the extent that automotive companies can come upstream and support with funding, that's very welcome. But more is needed. More than funding. There is also technical support and all these different things that we need to develop in this part of the world in order to be able to build these supply chains and have any chance to replace materials that are now being supplied by China.
Yeah, absolutely. And just quickly, what is the processing capacity, for rare earth elements, and then the separating process within BC, Canada, North America, for instance? It's obviously quite significantly behind China, but there's some facility, right?
Right. So today is about 15 to 16% of the total world mine production of rare earths that comes out of North America, more specifically Mountain Pass. There are some really very small amounts, bulk type samples coming out of Canada, but nothing so far which is material. Defense Metals wants to produce 25,000 tons. At the current world production, that will equate to about 10% of the world production. That is sizable. That is that will put a dent in definitely outside China demand for rare earths.
Yeah, excellent, very good. Well, Luisa, thanks very much for providing a snapshot globally of where the industry's at, and then also honing in on really exciting developments that you've got going on with your projects. And we hope to catch up later in the year as you move closer to the PFS as well.
Looking forward to that. Thank you very much for having me.
Yeah, thanks.